And we are live. We'll wait for folks to filter in here, and then we will start in a few minutes. All right. Well, welcome to Merge PHP for January 9th, 2025. Pop off the camera and share some slides. So we've got um, Merge PHP is a group of a bunch of PHP user groups across the US and Canada. And, well, so I hit the. Okay, there we go. Um, we're a bunch of user groups for the PHP community across multiple countries and multiple time zones, bringing you an online experience for learning new things about PHP and PHP adjacent topics. Um, Now, if you don't already have what I would consider to be the best PHP IDE out there, sorry, Visual Studio Code fans, then hop into the inbox of Chris at atlantaphp.org. Um, First one in will get a 1 year license to any single JetBrains product. The portfolio has grown, so if you want to rewrite it all in Rust for some reason, they have Rust Rover. If you like zero values and lack of ternaries, you can get Goland, or you have um, PHP Storm if you want to actually write PHP, which I kind of do at this point. Um, we are now on PHP 8.4. It is in active support for the next 2-ish years, um, and then get security fixes for another 2 years after that. If you are on PHP 8.0, it is out of support. If you're on 8.1, you've got security support until the end of this year. 8.2, likewise, security support. You're not going to get any additional bug fixes for anything other than security fixes. If you're on 8.3, you'll still get bug fixes for another year. And, well, 8.4 is the new hot version. In terms of upcoming events, we have a fair number. Um, Most of them are either online or not in the US, with something online. Um, Not sure what's going on with the second one there, but um, PHP UK is in London. It's a shorter version this time. Um, we've got Japan, Montreal, and then this new Symphony Day in Chicago that just got announced. If you Google that, you'll see a little bit more information. They don't have a venue last I checked, but a bunch of Symphony speakers there. Dutch PHP conference around the same time. And then, yeah, we need to get this calendar cleaned up because there are a few duplicates in there. And then PHP Day in Italy, and then another Chicago-based conference, PHP Tech, which will be interesting to see what their lineup ends up being for speakers. And then IPC, that's it. We are perennially on the platform formerly known as Twitter, on Mastodon, and you're watching us here on YouTube, either live or as a recording. You can follow those accounts for updates on what's next, and remember to post that. So next month, you can look at, you'll see Eric Poe's presentation of what's new in PHP 9. Yes, 9, because RFCs for newer versions of PHP are already out, and we'll be looking at older RFCs to kind of chart a path to the future. So don't miss out on that. As usual, second Thursday of each month, 7 p.m. Eastern, 4 p.m. Pacific. If you have a talk idea, in php.io/speakers, or tweet or post at us on those platforms and see if we can get you added to the lineup. With that, I'm going to turn it over to Mark Nieberdahl, one of our organizing team here at March PHP, to talk about bug squashing with TDD. Sharing and drop on my camera. It's Mark. It's all you.
Okay. Thank you, Ian. I'll get the screen share down here. And we'll go with that. It's the wrong one. We'll just go to style. It's fine. Let's see. Nope. Yeah, it's fine. All right, we're going to talk about bug squashing today. This is again this at Cascadia PHP. It was a really good conversation that we had, and had a lot of good feedback on it. So I wanted to give it here as well, broadcast it here. If you know me, you know I like snowmobiling. This is a great time of year. We start to get outside. We'll start riding the mountains. Live in the western U.S. Over the holiday break, I made it up to our family cabin. There's a view off the back deck. Not a lot of snow yet still, about 3 feet of snow up there. Normally we get a little bit more than that by now, but hopefully we get some more. With snowmobiles though, I've learned that you always need to check the sleds before you go up. Includes regular maintenance, making sure they'll start, making sure they're running right, tuning them up for the season. Do those regular maintenance items, greasing them, gassing them up, putting the gas in, checking the oil, making sure so that they'll actually start up, because that's definitely been a problem for me in the past. It usually makes the trip go smoother. You can still run into hiccups, still run into problems, but if you do your preventative maintenance, it usually makes for a smoother trip. And so this was the trip I took with my kids, and we had a good time up there. We had a couple of problems, but we got off fine. So we had a fun time up there, enjoyed playing in the snow. When it comes to test-driven development, I see it as doing that maintenance, doing that work, testing things ahead of time, so that you're not finding issues when you're up on the mountain and you're getting stuck and having bigger problems. If you just take the time to do it right, then it can help prevent issues. And I've seen and heard stories, horror stories of people trying to snowmobile and having problems in the mountains, getting stuck and machines not working, catching on fire, and all sorts of fun things. So taking care of that maintenance makes it go smoother. And same thing with code. We don't want a dumpster fire of code. We want good, clean, healthy code that when we send it to production, it's going to be working well. So this will help with that. Question to ask yourself, have you ever used test-driven development to fix a bug? So think about that. Think about like where you're at in your code and what you like to do and what works for you. But think about, have you ever used test-driven development? And if you have, we'll go over some of these, hopefully some tips to get to improve. And if you haven't, hopefully this helps encourages you to try it out. And also a question to reflect on is your perception of if test-driven development is a viable technique. I've heard lots of arguments for and against test-driven development and testing as a whole. Hopefully this talk encourages you to do more test-driven development as a regular practice. Leaving, you should have confidence that you will know how to use test-driven development, what it looks like, how it feels. You'll be able to walk away and try it out tomorrow. Know some strategies to make that process more efficient, make it so it's actually practical and usable, and a focus on how to write tests that are highly valuable. So these are the best tests that we can write. Anytime we give a testing talk, I like to put this slide in here. This is a chance to make a change in your career. My experience has been that the developers who are most effective and have the best code architecturally have taken this chance to make a change and to write more tests for the code. And I have found that writing tests drives clean code. And so if you're using test-driven development, you're going to have clean code. I decided to ask ChatGPT about test-driven development. And while test-driven development offers many benefits, like I was asking, like why it's not heavily used, why it may not be, why people might be wary of it or jump back away from it. It said several factors contribute to why not all PHP developers adopt it. It listed out lack of familiarity. Like, okay, I can see that, if you haven't done it before. Perceived time constraints. And I agree with that one. If you're in the shop that's trying to get things out, you have managers or leadership that's like pushing against it because they just want you to get things out, right? They want you, hey, we got to get this out, hurry up, get it done. We're going to skip the test, we'll come back and add it later. Legacy code bases, while it's not impossible, it makes it harder to write tests and do test-driven development with legacy code base. It's fair, but it's a hurdle. It's not a blocker. Cultural resistance. I've definitely seen in teams where there's a cultural difference. Some are adopt it and some don't. And if the team doesn't adopt it, or you have people that are against test-driven development or against testing as a whole, it makes it hard for one developer to write tests. Misunderstandings about testing. There's different experiences people have had with testing, good and bad, and so that's a valid argument. I would make the argument, though, that when done right, it's effective and efficient and a good practice to follow. Tooling and framework limitations. I'm not so sure that's a big factor. All the IDEs I've tried out, and the tooling is really good. They all make it a good environment, ecosystem as a whole. Some teams focus on rapid prototyping. There's that argument that you would throw it away, so why write tests? That maybe small projects where you might make that argument, but generally speaking, I've found even with smaller things, I'll still write tests. and complexity of some PHP applications. Again, that kind of goes back to the legacy code base. A complex system should be written well, and if it's written well, it should be testable. So that's just kind of my take. Hopefully that eases some wariness there. Going into an example, let's say you have an application where you have to log in, and you have a password. And there's been bugs reported, right? So we already have it exists. This function already exists. People can log in with the username and password. But this is an existing issue. User was able to create a password that is too short. It's obviously a problem. Another example might be, user is able to create a password with no special characters, which also would be an issue. And user is able to create a password that is a commonly used password. So maybe you're trying to check against a dictionary of common passwords, but the password check is failed for some reason. These are all different scenarios that you can use test-driven development to resolve and to work on. You can write a test to do the password check to make sure it's too short and see it fail, and then you can make the changes and see it pass. So this is where we're going to focus in on, is test-driven development for bug fixes, where we can take this strategy to solve these problems effectively. We'll be going over why test-driven development for bug squashing patterns, test-driven development, bug squashing patterns, writing valuable tests, and then some more examples. Like I said, we're going to focus on bug squashing because I find this is the easiest place to start. You don't have to figure out the code as you're writing the tests, but you have this code that there's a problem with, and you can prove that it's broken, and you can fix it. So again, we're looking at existing code base, an issue's been reported. And, what that could be coming from the customer, which is like the worst case scenario. Generally, we don't want customers and users finding our issues. Maybe it's found by a stakeholder within the organization, like some of the product team during platform use. Maybe it's found by the QA team during a regression, or the QA team was testing a feature you added. Or it could be found by a developer during development, right? So you're writing stuff and the bug is reported. And they found something else that was already existing. Not a feature request, and this is not specific to greenfield development. Again, we're focused on existing code. Why do you want to fix these bugs? Improve the customer experience. We don't want customers finding issues. It's generally a bad experience for them. And if it's, assuming you're working on a project that has paying customers, it's going to help with customer retention. Also, the perception of your application is going to improve as you're able to retain customers because you're having fewer bugs. They're not seeing these kind of issues. So it benefits the company as a whole, which means more revenue, which usually means more secure job, and so on. So all good things for a developer. Test-driven development, that's what it stands for, of course. We've mentioned that quite a few times here. The cycle typically goes, you write the test. So you get the bug report in, you're writing the test, confirm that the bug is actually valid. And then you're running the test and you see it fail. So going back to the password checker, you could, if you had a password checker class and had a function to check password length, you could write a test that passes in, a short password, and you can confirm that it passes that validation. The test would fail because it should not be allowed through. So you can run that test and see it fail. You could make the change of the code. In this case, in the password checker, you could write, make a code change in there. If the length is less than the required length, and kick it out or fail somehow, return a false or throw an exception, whatever. And so you can write the test, you can make the change, and then see the test pass when you run it again. And so just rinse and repeat that just over and over again. And I found this is the for me, the best way to fix bugs. It provides in one pass a verification that the bug exists. So you can go in there and say, yeah, this is actually valid, this is correct, it's wrong. Identify the root cause. We'll go later into root cause analysis, but you can identify like what actually caused it, so you can know like boost and what maybe make some organizational changes from like code development practices, how you can improve to prevent that. And you can also validate and verify that the bug's actually fixed. Which for me, bringing confidence that I've actually fixed the bug. I know it's not going to come back from the QA team, or the customer's not going to find another issue with it because we have that bug in place. It's also going to prevent the bug from being reintroduced because now we have a test for it to prevent that problem. It's a more effective way to resolve bugs than maybe like clicking through the application, and doing these kind of things and setting everything up. If you get to go through all that work anyways, you might as well write a test for it. Generally, I find that it's faster to write the test than it is to go set all that up. And then you can just repeat it, and it helps speed up the development process. So you're not having to go reset data in the application. Instead, you're writing the code and you're just changing the code. And once you have the code in place, you can just walk through it. You can turn on Xdebug and so on to help walk through the code as well. I find that the time to resolve the bugs is faster. So if it normally would take 2 hours to resolve, it might take an hour and a half instead. Just like a rough example. It could vary quite a bit, but I generally find it is a little bit faster there. It also ensures your code coverage, so your code coverage is going to be covered by the test, and your code coverage overall is going to be going up as you're following this practice. And again, prevents bug regression, where the bug's not going to be reintroduced because the test would have to be changed in order to have it falsely passing again. So going more into the pattern and like what it is and how it is and why it works. So understand that, it helps you understand the bug. When you're writing the test, it helps you see the code, like understand like what's actually going on. When you actually understand the problem, then you're able to actually fix it. It also helps narrow down. I mentioned Xdebug. I love turning on Xdebug, and I'll write the test, and I'll just step into the code. And you can start walking through. You can actually see the variables, and you can see where the issue's at when you're doing this. It helps you write the test to recreate the scenario. So again, it's proving that it's there and that it exists. And then you actually fix the bug. The test will pass. Standard pattern there. Understanding the bug, it's important that you actually read the details. There's been too many times where I haven't done that. I've been trying to hurry and get things done, and I just don't read the details. So I have found that if I slow down just a little bit, make sure I read the details, make sure I read this, setup scenario and so on, it helps speed up the development time, the bug resolution time. As I'm understanding the bug, I'll also write, this is an opinion here, but I like to add behavioral-driven development verbiage to my doc block on my PHP unit test functions. So along with the at param or at return and so on, I'll have a at given, at when, at then. So BDD typically is given, when, then, and so I'll have the at tags in there, at given, at when, at then. The at given states the scenario. The at when is the action being taken, and the then is the expected outcome. So, for example, if you have a function that needs to add numbers, and you say at given a non-numeric value, when adding the values together, an exception, or then an exception should be thrown. It provides a user-friendly, understandable for anyone to come in and read that, and they can know what's going on. They can see what's, understand the test. From a developer standpoint, it helps new developers, or if you're coming back to your old code or reading someone else's code, you can read this behavioral-driven development doc block and understand what the test is doing beyond just the function name. So it gives more context and understanding to what actually is being developed. You can add multiples, so at given multiple times. So if you're adding a non-numeric value and an integer value, you just do given double time. You can also say then multiple times, as an example. So exception should be thrown and error should be logged. So if you're, for some reason, testing a little bugging or something. Identify the bug location. It's important, of course, to know where the bug is at. And so I find that when I'm doing test-driven development, it helps me narrow that down, find it faster. It helps understand what's going on from the bigger picture of the code base, understanding where the code base is impacted at. Help from the bug description. Usually the bug description will include a click path or how to trigger this issue, or maybe it's an API call or some sort of process, some sort of resource that's going on being triggered. Going to root cause analysis. As I mentioned earlier, when we're doing test-driven development, it helps with understanding why the bug was introduced. It helps improve the organization, helps improve the team, helps improve everybody that's there. And it identifies areas where you can change. So, it might identify, hey, we have this technical dead area that we know we need to resolve. It might be that there's organizational issues. For example, it might be missing not enough QA. Or maybe we need to slow down as a development team and spend more time on quality of the code. Maybe it's identifying that we're missing requirements, and so we need to work with product to make sure we get more requirements back. It might identify that we have complex code and that it's fragile and that breaks. The intent here and emphasis is not to point fingers. It's not to blame specific people. Rather, it's an improvement process. The root cause analysis helps with becoming better as a team and becoming better as professionals and as a developer to improve our process and streamline things. So that's the intent of the root cause analysis when working on the bug. You can identify also if there's any tests covering the bug. There's been many times, not many times, multiple times, when I've stumbled on an issue and the test is not correct. And so it really helps understanding when we have the bug location, that we can identify other tests that are covering that same area, whether it's for a code coverage report, or usually they're organized in a way that makes sense to find it through method, looking to see where the methods call from and so on. But we can check to see if the tests that exist are actually incorrect. If they're incorrect, we can fix those. Maybe a test is incomplete. I've also definitely seen that one, where a test was written against code, but it doesn't test all the different code paths, or it doesn't test that the code paths do what they need to do. And so sometimes the test-driven development is adding completeness to a test that was lacking completeness. You can also look at how tests can be improved. So if a test is the poor quality, you can look at adding, making it better. Going back to the different paths, so maybe a test was added for the function, but it doesn't go down the specific conditional. And so we can create a new test or modify the existing test to cover that area of the code. We're going to ask the question, are new tests needed? And that's often the case, that we need to add new tests. Write test to recreate the scenario. So when we're updating existing tests, we want to really avoid making tests that are too complex. A unit test should never have an if or match or for each or other sort of logic structures in there. You can typically ask the question, if you get into that, would a data provider be a better approach here? Data provider provides multiple data sets to one function or one test function. So it can use that to pass into another function and there to increase the coverage typically. To run through various scenarios. So I love using data providers. It's a good option, especially if complex code, to make sure we're actually touching through all the different scenarios without having to go copy and paste a whole bunch, tests multiple times. But really an emphasis on code tests should be simple. It should not be complex. We'll go more into that a little bit later. But so writing tests, I'll start with a test of the BDD doc block. If I write that first, then it helps give me direction of where I'm going. And so you can put the context in there, if it shows that you're understanding what the bug is, and drives your development as you're going along. I give the function a descriptive name. So going back to the password checker, the password's too short. My function might be test password checker is password long enough, or something like that, or is password too short? And so giving a descriptive name will help understand what it's doing, along with the BDD doc block. Making sure you're asserting the correct behavior, not the incorrect behavior. So writing new tests, we have unit tests and integration tests. There are, I think there's like 5 or 6 technically different types of tests. I usually lump them together into unit test or integration tests, where unit test is self-contained and not going out, and it's testing the actual logic in the isolated function, and integration test is actually able to go out and reach into things. I know it can cover functional and other types of testing, but I generally lump them into unit integration. We want to make sure we're writing valuable tests again, so we're not just writing tests just to write tests, but we're actually writing tests that have a purpose, have a reason, not just to bump up the coverage or something. We're not generally trying to test language construct. I think those are pointless. Generally speaking, the test should be actually testing logic, not language constructs. And test absolutely should fail to verify the bug. So you should have a failing test when you're going into it before you go make changes in the application. So now you actually have it set up and ready to fix the bug. And with that good test in place, that's actually verifying the test, or verifying the issue, and has pointed us to the right spot in the code base. Now we can go make the change, and the test should start passing. And we can know for sure that the bug is passing because we understand the context, and the test will tell us if we've actually fixed the issue. Writing valuable tests. There's a lot of bad testing patterns. I mentioned earlier avoiding logic in your tests. If, for each, while, match, switch, so on. If we're having those kind of things in there, now you have to go write tests for your test. And so it creates this endless cycle of mayhem. Because what if your logic's wrong? What if you think through things incorrectly? Then we have a different problem. And your test might not be accurate, might not be correct. It's better to copy the code, the test, and change things out with a new function than it is to have ifs and for each and stuff. Each test should be targeted and specific, and should not have conditionals going on inside of it. And also, we should avoid that tight coupling. So tests should not be calling off to other functions inside the test class. Generally speaking, we might have a setup and a teardown, which is fine, but we shouldn't be having functions that are being called off, generally speaking. There's a few rare exceptions, but generally speaking, it's a bad practice. So making our functions independent, our test functions independent. Use a data provider. That's what it's for, to provide that data to it. I do appreciate that the data provider remains static, because that really emphasizes that they should not be called and used. Also avoid just complex tests. Again, that if you're having conditionals, it's going to be complex. It's going to be doing too much. So just as a general practice, follow there. Good testing patterns. A test should be really easy to read. You should be able to look through it, skim through it, and understand it within a reasonable amount of time. It shouldn't be a long process to understand it, to read it and to understand it. It should be self-contained, like I mentioned. It shouldn't be reaching out to other functions. It should be all self-contained. There's a general pattern of the AAA, not the company. This is the arrange, act, and assert. So arrange, typically we have the variable declarations at the top of the function. Making a mock or setting some values or whatever. And then we act, we're going to be calling into the code base, calling into the function that's has a bug in it, and passing in the values or whatever. And then we're going to assert that the outcome of that function. So the range, act, assert is how the code should be structured. The test should be structured, ordered. Code coverage. I've heard varying opinions on this one. What is the optimal code coverage percentage? I don't think there's a magic number. I think you can push too high. So I don't want to set the bar too low either. I generally find 80 to 90% is doing pretty good. I think if you get above, if you're going for 100% code coverage, you're not adding valuable tests. And you're generally testing language constructs at that point. And so I don't aim for 100% code coverage. If you get it, great, but that's not what my target is. I'm really going for valuable tests that are testing things that I actually care about and actually need to be tested. Logical tests rather than testing some language constructs. So a language construct example would be verifying that if you pass a string to a typed, trying to set a string on a typed property, it's not going to be allowed. Like that's excessive. We know that's not going to work. Always throw an exception, so you don't need to test that. You can know that a string should not be set on a different typed property, or a bool set on to a float or so on. We don't need to be testing that kind of stuff. Types of tests. I mentioned earlier, I also categorize them. There's manual testing, which would be like clicking through the UI, and maybe a QA team has the regression pattern or process that they follow. So this would be like the manual testing, clicking through. Automated would be anything that you can kick off. Usually through a CI tool, continuous integration tool like Jenkins, or Bitbucket has pipelines, and many other ways you can do that. Then there's unit and integration. I usually bunch things into that. There's functional and others. Atlassian has a good write-up. I don't have it linked here, but they have a good write-up describing the differences between each different automation test type. They go into the details of what's there and what's not. What types of tests are ideal? It's kind of a question that we might have. So really the type of tests that are ideal are ones that are going to be verifying that we have the bug, it gets fixed, it's not going to happen again. And type of test with this functional unit will just vary depending on what you find, what's going on with the bug. A unit test might not be able to verify that a SQL statement is behaving correctly. Maybe you have a join wrong, or you're missing a conditional, or so on. And a unit test won't catch that. So then we need an integration test instead. And vice versa, if we have a simple function that's just doing logic in it, we want a unit test. If the function's not calling out to anything, if it's not using a database, if it's not calling an API, and so on, unit tests are a really good approach for that. I will often have both tests. I'll have unit and integration tests, depending on what it is, but double coverage essentially for things. It's a little bit nerdy, but I like doing that. So again, we've done through. Hopefully, this gives a good introduction to test-driven development and helps you be motivated to try it out if you're not doing it. You understand the benefits of it, knowing especially that it's going to increase your development time. You're going to have higher confidence in your bug fixes, and you're going to be able to make sure that those are actually fixed and they won't get broken again. It's a classic problem to have bugs reintroduced because developers don't understand what's going on. But if you have a test to make sure it doesn't happen again, that's the best case scenario. We've gone over the pattern. So again, we write a test, the test fails, we change the code, the test passes. So we can follow that pattern as we're writing these tests. And then we can write these valuable tests. We're not just writing tests just for coverage, but we're also writing tests that are actually going to provide value. They're going to be testing the logic, they're going to be testing that things are actually behaving correctly. And they're going to be tests that we can use to improve our code base. Jump over to questions. I haven't been watching the comments, so I'll check on those. Let's see if there's any comments there. Not any comments or questions yet. If you find me at another PHP conference, if you want to chat with me, a little bit about me. I work at a cybersecurity company on a vulnerability management, deal with billions of records and some big data scaling. And I organized the Utah PHP user group and do a bunch of things outside as I alluded to, runner, cyclist, and so on. That's what I have. So thank you. Logan, we'll see you back up here.
Thanks, Mark. Thanks, everyone, for joining us. So we can bring a few people up. Where's my camera? There we go. Good to see you guys.
Yeah.
Did you have good New Year's?
It's fun. It's been a struggle to reboot everything in my brain this week, though, and like get back in the swing of things.
January is not slowing down.
Hey, Chris.
Can you hear us?
Okay.
Oh, there you go.
Hey, sorry, yeah. Sorry, my device got all out of whack, so like my camera switched, and I couldn't tell until the mic was on or anything. But anyway, I'm good. I'll have to look this way and look at you guys over here. Let me see how you switch the camera.
I'm so bad at that, like looking at the camera.
Oh, wait a second. It should work.
Did you have a chance to check your email during the talk?
Me?
Yeah.
Yeah. There. I was gonna say there's been no JetBrains requests at this time. So.
Okay.
Refresh.
We'll keep an eye out.
Email's been very slow and finicky for me lately. Yeah, nothing new. Okay, that's a little easier.
Lena, do you want to come up? Okay. I don't know.
Sure. Hey. Hello.
Hello.
So did you convince everyone to go to tech at the beginning? Sorry, I missed the first part. Is everybody convinced?
Ian mentioned it. I'm planning to go. I hope to see a lot of you there.
Sounds fun. So it's always a good time.
It's a good coffee.
Right,
Good
conferences
conference.
conferences are always good to go to.
Yeah.
I'm excited. I'm going to be speaking about codeception, so doing browser testing, which is super fun, and I will definitely be throwing in the behavior-driven stuff because I think that's so important for communication. So I think one of the problems that testing in general can help solve is making sure, as Mark mentioned, that we understand the requirements, whether that's because we didn't read them or someone didn't give them all to us, whatever. And so I appreciate the TDD style of just the Gherkin syntax of the given, when, then, because anybody, even non-technical people, can talk about it in that way, and it gives you a shared language that everybody can talk about instead of getting really technical about like complex conditions. Well, what happens if this and that, and so it's definitely helpful when it's coming to making sure that you have those requirements.
I've seen it work really well with the QA team for communication. Because if the QA team finds a bug, they can give you, say, this is my, they can write it in Gherkin, give it to you. You can copy and paste that, put in a test, and write the test for it. So it's super handy for that way too. So then, like you mentioned, it's not just the developers, but QA, product, and others can understand it.
For sure. Yeah, I found it's helpful when you're talking with product about what's going on. Like, okay, great, let's talk through this. And instead of me trying to throw out all these technical things, and the product people are going, wait, that's too much. I'm like, well, I need to know these things. Given this, when I do that, what should happen? And they're like, oh, okay, well, that makes sense. And it's a lot easier, I found, to get product on board with talking about it, because they want to give requirements. So having a shared language that we can use is helpful.
Kind of helps me too with writing my tests, because then I'm more focused on what needs to happen. Gives me like a pattern, a guideline to follow. I got to set this up. I got to do this. Sort that.
Has anyone tested Claude or ChatGPT on like how good it is to assist with writing front end tests?
Ooh, front end test. No.
I'm sure someone has. But someone is not me.
Yeah.
When I write a good TDD doc block and then a good function name, test name, the ChatGPT, or I'm using Copilot, but it does really good at helping you write the test.
Right.
It'll generally generate most of the test for me. I'll go tweak it and stuff. But if I write it really well and coach it along, it will generally produce pretty good code.
Yeah, if you just think about ChatGPT or any of those things as a intern that you have to give very clear instructions to, right? It's all about the prompt engineer, right? It's all about giving very clear instructions. And when you can do that in a simple format, that's easier for both you and that intern to understand, can be helpful.
It probably could write Gherkin pretty well if you give it kind of like a stream of thought, like description of what you want it to do. What's that? I was asking it the other day and it did like a diagram. What I can't remember the name of the
Probably mermaid.
Mermaid, yeah. I was gonna say dolphin, but that doesn't sound right. Yeah, and it does mermaid fine.
Nice.
Good one, y'all. See ya.
See you, Ben.
I have a couple talks I'll be giving at PHP Tech too, so I'm gonna start getting those ready now. So I'm past this one.
Getting prepped. They'll be here before we know it.
And I am definitely going back to the Art Institute of Chicago. So if anybody is interested in going to the Art Institute of Chicago, it has been by far my absolute favorite museum. And anybody can appreciate that was just so well thought out. It's not just the exhibits, it's not just what's in the exhibit, but the way the exhibits are put together. And there's so much stuff. It's not just like art. There's, historical things in there and stuff. It was fabulous, absolutely fabulous. I definitely am going to try to make that work when I'm in Chicago. So if anybody is interested in going to the Art Institute of Chicago, hit me up because I will be going.
Does sound like fun. I think I've been there once, like long time ago, in a galaxy far, far away.
By the way, I believe we're still live.
Oh, yeah. Well, so I guess we should should we end the stream? Thank you everybody for joining us.
Mhm.
Yeah.
Yeah, it was great. Thanks for presenting, Mark. Appreciate it.
Thanks for attending. Thanks for watching.
Thanks a lot, Mark. Great talk.
Thanks, Mark. Bye, everyone.
Bye, everyone. Until next month.
All right.